Hi, good afternoon all. This is Vijay, your room host for this session. Thanks for joining the session. Before we start this, just quick notes. Please keep your devices on silent. And a reminder to download the AWS Events app to provide your invaluable feedback. With that, I would like to invite on stage Blair, Principal BDM Transformation, as well as Saeed, Senior Specialist Solution Architect Analytics, to talk about transform your data approach.
All right, welcome everyone. So this is an after lunch session where everyone's getting all warm in the tummy, is it? And relaxing, please don't fall asleep. So as was introduced, my name's Blair Layton. I've been at AWS for nearly 10 years, seen a lot of change in that time, and focused on helping customers modernize their applications and transform them on their whole IT environments when they come into AWS, and focusing on data. And I've got Saeed today with me.
Hi, my name is Saeed. I'm the Analytics Solution Architect, and I cover public sector across APJ. I'm not as tenured as Blair. I've been here for just over 1 year.
Cool. So as you can see from the attire, I'm going to be doing the talking, and Saeed is the technical guy who's going to do the demo. All right? So let's get on with it. This is the session for you if you're here to find out about modern data strategy and how you can transform your data approach. So what's the agenda? First of all, we're going to be looking at what is driving change in data strategy. Why are you here, probably? Looking at developing a modern data strategy. What are the things that you need to consider? And then looking at the journey from ingestion to visualization. How do you tackle each of those stages? Looking at what AWS has in terms of its purpose-built data services. And then looking at modern data architecture on AWS. And then finally data sharing before we get to the demo, and then we'll have a recap. So what's driving the changes in data strategies? What we're seeing, and you've probably seen slides like this before, is that clearly there is growing data that you're having to manage all the time. Then there is also data coming in from news sources. And then it's increasingly diverse. So it's no longer just your traditional OLTP system data, used by many different people. And then lastly, which is an interesting one, it's been analyzed by many applications. And we're seeing more and more operational systems calling analytical functions as part of the overall system. So we're starting to see a tighter integration between operational analytical systems as well. Now, what we're seeing from a kind of historical perspective is that on the left-hand side here, you've got a traditional data warehouse. And in that data warehouse, you've got your enterprise resource planning software putting data in. You've got your customer relationship management, line of business, and other OLTP systems. And that data warehouse was built. It was operating fine. And then as time has come, we've got new data sources. We've got web data. We've got mobile application data, perhaps sensor data, or even social media data coming in. And it was very hard for customers to take that new type of data and put that into their traditional data warehouse. So then they created another data warehouse. And then you end up with a silo approach. And of course, this can be magnified across many different types of organizations that are quite large, where they have data warehouses and individual lines of business. So then what customers are doing is moving towards data lake. Now, one of the key things that AWS would believe is you should be putting your data in open formats. So that's a key differentiator. We want you to be able to put that data in so that you can get it out if you need to. And then you're going to build your machine learning, your data warehousing, AML content around that central data lake. Now, if you're looking at where are you today and how do you actually feel about your data maturity? This is an interesting slide, especially when we use it in person with customers. You can see on the left-hand side, you've got basic management reporting. So that's just delivering an email with some annotations and here's some data about what's happening. Then to the next level, people started to use spreadsheets and they were able to take control of that data, visualize some of that data, and there's still a lot of people who love their Excel spreadsheets. Yeah? And then, of course, people realize, though, if you send a spreadsheet, as soon as you've done that, it's out of date. And then someone else sends another spreadsheet, you come to a meeting, you think you've got the same version, and people have got different data. So then they realize that, hey, let's put this data in these application systems in a database, and then you'll be able to query the data from that database at the point in time and get an accurate view. So that was the first big challenge, getting from that environment where everyone was familiar with Excel spreadsheets, moving to there. Once we got across there, then people said, well, hang on, now we've got data in all of these different applications. Now let's build a data warehouse. And of course, that data warehouse, you could have had one for one line of business, another for another line of business, and so on. So then the big challenge, how do we get the enterprise view of what's going on? And people started looking at enterprise data warehouses and data lakes. And that was really harder than anticipated. When I talk to customers, there's a lot of challenges around people trusting the data in that central environment, the lineage of that data, obviously. And what tends to happen is that people end up not quite trusting that big system and still using their own. Now, some customers have obviously done well. They've got to that point and they're able to then do great insights across the business, use AI, ML, and so on. So the question is, where are you in this journey? And when I ask customers this, I'll have some people say, oh yeah, we're at level 5. And someone in the same room says, yeah, we're at level 2. So there's lots of customers with varying capabilities across here. Have a think about where you're at. So when you're looking at developing a modern data strategy, there's a number of different things that you need to consider. Now, the first one here is, I would argue, the most important. You want to avoid building a science project. You've got to focus on what is the business outcome that you're trying to derive, and therefore, what are the insights that you're looking for. So once you understand that, that helps you look at everything else. When you look at the tools, again, you could go and build out everything and look at the wonderful capabilities, or you could focus on what tools that you already have and what new tools you could use to solve the particular business insights that you're looking for. And the next one is leadership. Ideally C-level, but senior people in your organization who can drive change. Because if you're going to be doing something different, you're probably going to hit some political barriers. You'll need some management to get through, either get access to data, get some teams to modernize, try different things, and push that change through the organization. Then you want to be able to get to that stage where you've got a data ecosystem. Ideally, where you're looking at building a self-serving environment where you can actually go, get data, and find the insights that you're looking for. Now, one of the key things to help do that is you're going to need skills. So this could be, you could look at it from different angles and bring in AWS partners to help you with that and educate your own workforce, get training, or go through and obviously just do proof of concepts and get people up to speed internally. But you have to look at where are the people today and what new tools and processes are you going to look at and how do we need to get people there. And then the continuous improvement is important. As I said, I've been with AWS for quite a while. When I joined from an analytics perspective, Hadoop was the cool thing. Yeah? And then there was no Spark and anything about that ecosystem that had moved on. So now you've got all these new tools. If you don't keep looking at all the new stuff that's coming out and being able to integrate that, you're just going to end up with a legacy environment very quickly again. Next one, governance. Now, again, we see some customers who go and try and solve all of the governance issues across their organization, produce wonderful documentation, and they never get started. So what we say here is that it is a combination of things. It's people, processes, and technology. You can't just come to AWS and say, can you solve my governance problem? So you've got to look at it and think big. Yes, you've got to look at, okay, how am I going to govern my data across the whole organization? Build an architecture around that, but only implement what makes sense, again, coming back to the insights that you're trying to derive. Because as you start putting use cases through, then you'll build out the capabilities around the governance rather than trying to solve all of the governance problems first. And that will allow you to move fast. The next one is the journey from ingestion to visualization. Now, the diagram here is a left to right diagram. This does not mean that you have to start on the left to get to the right. What I wanted to get to you across here is that each of these stages, whether it's the data sources that you have to choose, the ingestion mechanisms, or how you're going to store that data, how you're going to do analytics, AI/ML, and visualization, you need to consider that and look at what's available in the marketplace, what AWS has, what our partners have, and how that's going to solve your problems. At least get an idea. But again, we see customers who build massive paperwork of this is all the comparison against all these different things, this is all the different products, diving deep into all the details, and 6 months later they still haven't done anything. So what we'd like you to look at here is, again, think of the insights that you're trying to solve, and then which of these areas do you need to focus on to do that? Perhaps you do have an AI/ML problem, but you can do that by just putting the data in a store and manipulating it directly. You don't need to worry about some of the other layers. So again, think about the problem that you're going to do, and across this stack, what are the components of a modern data strategy that you need to solve that problem? Now, when you've got that understood, then you go into what does AWS have in that space? Well, funnily enough, we've put this in the same segments. So we have a bunch of services on the left-hand side for doing data movement. That could be the first one is the database migration service, where you can do change data capture, so stream data from a database that's happening on-prem perhaps into AWS, all the way down to streaming services and all different capabilities there, including physical devices to move data from one place to another. Then from a data lake perspective, we've got AWS Glue for ETL, AWS Lake Formation to help you get a data lake up and running very quickly. And then from a storage perspective, Amazon S3, which is the central storage for most data lakes that customers build. Next one on the databases. There are a bunch of purpose-built stores here. Now, it doesn't matter whether you're using open source or whether you're using commercial. We've got the relational database service there to manage those for you. And then there's a whole series of purpose-built databases, some of them to do things like Quantum Ledger database. What's that about? Well, that's a ledger database. And in fact, SkillsFuture here in Singapore has implemented that in one of the services, which is a blog on that available now on our website. And then there's things like DocumentDB, which is compatible with MongoDB. And then you've got something like Amazon Neptune, which is a graph database to solve graph problems. Then the next one, we've got blockchain. And then the next one after that, a series of analytics services, such as Amazon Redshift for data warehousing, Amazon Athena for interactive queries. So you can see how these all relate back to that previous slide, right? And then on the last one, business intelligence and machine learning. If you want to do visualization, we have Amazon QuickSight. If you want to do analysis of text and extract text, we've got Amazon TextStract. So there's a whole bunch of services there for you to do that. And for machine learning, we've got Amazon SageMaker. So what does it look like? Whoops, helps you push the right button. When you move to a modern data architecture on AWS and you combine all of this together. Well, we believe that you need to have that central data lake, and then around that data lake, you're going to be using relational databases, non-relational databases, machine learning, data warehousing, as well as log analytics and big data processing. Now, all of this means that data doesn't just move into the data lake or out of the data lake, but it also moves around this ecosystem. So if we move to the next one, which actually shows you the AWS services, you can see here, it's quite conceivable that Amazon Aurora, which is for relational databases, for MySQL or Postgres, can call a function in Amazon SageMaker to solve a machine learning problem directly. It doesn't need to go through the data lake. So we see that you're building a scalable data lake with these purpose-built data stores, and that data is moving seamlessly around it, all with unified governance. And of course, you're only paying for what you use, so it becomes cost-effective as well. Now, what if there are multiple data providers, domains, and consumers? And we're starting to see this map in public sector quite well to examples like health. So if you think of health, you'll have a hospital, then you might have a cluster of hospitals that need to share data, and then you need to report that up to a department or ministry. And then perhaps, and if you look at Australia, for example, you've got state governments and you've got federal governments, and there's agencies you need to share data with, and so on. So that you've got these complex organizations where a central data lake doesn't necessarily work for everyone. So here are some of the challenges with a central data lake management approach. You've got misalignment between the business producers and consumers, and that means that the people wanting to use the data are not necessarily getting what they want from the people who are producing the data. You've got a lack of data ownership and accountability, and it's difficult adopting that multi-regency or multi-agency structures that I mentioned using health as an example. So this results in a slower pace of innovation. You don't get the collaboration between the teams. And the last one there, which is emphasis on using data rather than making data more usable. And I think that's a really important point where we want to be getting people to think about how I've got this data, how can I make it more usable in my organization? And it requires a different change of thinking for that. So what is a different way of looking at this? It's a data mesh pattern. So I'll read off the definition here. A data mesh architecture empowers business units organized into domains to have high ownership and autonomy of the technologies they use. So if we're looking at the problems, remember that we've got all these different organizations who've got data. Now we've organized that into those domains, and they have decentralized data ownership and architecture for that. Then they evolve into creating data products. They're responsible for that data in that domain, and they can produce products to give to consumers of that data. And then it becomes a self-service data infrastructure to support that, where consumers look for data that has been published by the producers, and they're able to choose what makes sense to solve their particular problems. And then you end up with a federated computational governance. And what we mean by that is that, remember, if you centralize all that governance in one place, it becomes very heavy in that centered place. We want to be able to say, no, if you understand this data in this domain, you manage the governance for that, and then we have a central governance for the shared components. So it's a different approach. There are pros and cons, though. So on the pros, obviously we get that distributed control, we get increased adoption of data, and it encourages that product thinking. On the cons, though, if you're not used to managing distributed environments, and this is the same if you move from, say, monolithic applications to microservices, anytime you take that jump, it does require different skill sets and different thinking. Also, for smaller organizations, it doesn't necessarily make sense to go down this path if the number of domains is not as complex, or the complexities in your organization and who you need to share data with is not as complex. So it can be difficult to audit. There are obviously ways that we can help you with that, but you need to put the right mechanisms in place to show how that's going to work. So what does it look like when it's a data mesh? Well, that same model that we had before, the modern data architecture model on AWS, is there. And then we're going to put that into a data mesh, so you can see that each of those components represented by this is now able to share data and publish data among all the others. So if you're going to build a data product, this is what it might look like. You can see now that we've got a domain that is here in this box. The data is in S3. They've got QuickSight for visualization, Athena for ad hoc queries, Glue for ETL, and then we can use AI and ML services such as SageMaker. Then once they've done the analysis and produced the data on that, they can publish that out to AWS Lake Formation, which has got the catalog and the governance around permissions to be able to do that. And then you've now published this product into the catalog. So that's one view of a single product. And then on the next slide, you'll see now that we've got a whole set of producers on the left-hand side, which are publishing that data into that central governance platform. And then on the right-hand side, we've got the consumers coming in. So each of those accounts and the environments in there, they can still have their security and governance in that environment. And then the central one is the federated approach, where you've got your own governance and the central governance coming together. And this is a view from a customer, which was JP Morgan. And you can see that it is almost identical to that previous slide in terms of the architecture. And this is from a blog that was published. And you can see we've got the business systems on the left. We've got 3 different data lakes. And they're then putting that data into the catalog, and then the consumers on the right-hand side. And there's information about this. I won't stay on this slide for too long, but there is a blog link on here. When you get the slides after the session, you'll be able to see this and go and read what JP Morgan did in terms of how they built this out and validated that architecture. Now, once you've got this data mesh in place and you're going, right, so we've got all these pieces of data everywhere, how are we going to share it? Now, there's different ways that we can do that on AWS. The first one is the very simplest one. Imagine you're just a basic entity. You don't have that complex sharing across different environments. You just want to be able to do that internally. Well, normally if you want data from the system, you have to ask somebody to create a data pipeline. They've got to do ETL, pop that somewhere, and then you get access. But what if you're able to get access to that system directly? Well, Amazon Redshift and Amazon Athena both support federated queries that allow you to execute the queries back on multiple systems directly, rather than having to do the ETL process. The next one is AWS Lake Formation cross-account sharing. So in this example, we've got the producer and consumer model again. The producer is a hospital cluster, and they've got information on their finance system, what the operational aspects of the hospital, and the electronic health records. And they're going to share that to the state government, who's a consumer. Once that has been shared across, then they'll be able to put additional access privileges in the consumer account to decide who's going to have access to that data and view it. And keep in mind that this is a soft link. So that means that the data is still being accessed back to the original account that the producer has put as a shareable set. And that means that you're not copying the data around everywhere. You're just getting live access back to that original share. We also have the capability with Amazon Redshift data sharing to be able to give you the capability to have a data warehouse and define a data set in that data warehouse and share that across other AWS accounts. And this allows you to then have a data warehouse with access to your own data and then have access back to the shared data as well. So you can combine data sets from different clusters of Amazon Redshift. Now this, again, gives you that live view of the data, so it's transitionally consistent. You're not copying that data in again. You have your own data joined with live data from somewhere else. And this is all secure and governed as well. And then the next one is, what if you want to take this data that you're able to share and make people aware of it? Well, we have the capability called AWS Data Exchange for Amazon Redshift. Now, this allows you to put your data sets up essentially in a public catalog, and you can even monetize it. So you could have, say, a 6-month subscription model, and the consumer can come in, choose that, they will get billed through AWS, and that money will come back to you. And then if that entitlement ends after 6 months, they will lose access automatically to that data set. And the same principle applies. They're getting access to that data that's in that governed account, and you'll be able to see who's getting access to it and what they're doing with it. Now we have the demo. I'll get Saeed to come up. There he is. He's moved over the left. All right. Now, I'll just apologize on Saeed's behalf. I've dragged him all the way from Australia, and we had to do a recording. So you're going to hear Saeed talking as the recording that he's done. It's much better than the Canberra Summit because he was very sick and coughing during the recording. So this is a better improved version.
Yes, I guess Saeed 2.0.
Yeah.
Okay, so I'm going to show you a demo about a very important characteristic of modern data architecture, which is in situ and no movement data sharing. The scenario I'm going to cover here is mainly health focused and covers a scenario when a patient who has been in an accident or maybe have had a stroke and is non-communicative is brought into emergency room. So for the doctors and nurses in the emergency room to be able to provide the right level of care for that patient, they might need to share the information about that patient with the specialist and get their feedback. At the same time, they definitely need to know about any food or drug allergies that this patient might have. And that information might have been stored in a wider data lake, S3-based data lake, let's say at the health department level. So in the demo, I'm going to simulate patient information streaming from medical devices into Amazon Kinesis Data Stream, which is our streaming and real-time service. And from there, that information is delivered into Amazon Redshift using Kinesis Data Firehose, which is our near real-time stream delivery service. And then we will see how just using a few commands, we can share that information across to another Redshift cluster. So I have created a table in my Redshift producer cluster that will capture records coming from medical devices. It has a few different columns such as the event time, the Medicare hash. Medicare is actually a number that is assigned to all Australian citizens using Medicare service, the sex of the patients, age, arrival mode, if they have any injuries, and other information such as their blood pressure, heart rate, and body temperature. If I query this table and sort it by event time, we can see that the latest record in this table is actually for 26th of September at 11:42 a.m. I also have a script that simulates the medical devices generating records, generating data about the patient, and sends them to my Kinesis data stream. If I run this script now, it produces 2 records every second. One is for a patient who had a stroke, another one for a patient who had food poisoning. So it is going to generate the few records for us. Let me stop that and go back to my query editor. As I mentioned before, the Kinesis Data Firehose is a near real-time service. What it means is that it's going to read the data generated into the Kinesis data stream and group them at 1 minute interval and push the records to the data sink, in this case, our Redshift cluster. So what it means is that we need to wait for 1 minute for the new records to appear in our Redshift cluster. However, we recently announced a new feature for Redshift, which is called Redshift Streaming. And using this new feature, we can bypass the use of Kinesis Data Firehose. What it means is that in this case, Redshift goes directly into Kinesis data stream and reads data directly from their streams. And in that case, we can support latency of a single digit second latency. And as the records are generated and pushed into Kinesis data stream, they will appear in our Redshift tables in less than 10 seconds. I guess 1 minute has passed. Let me run this query again. And now we can see that the records that I just generated have all landed in my Redshift table. To share this data with the consumer Redshift cluster, there are only less than a handful of commands that we need to run on the producer side. First, we need to create a data share and set the public accessibility to true. This does not mean that anyone from the internet is going to be able to query the table now. It only means that whoever will get access to this data is going to be able to query data in situ. Then we alter the data share and add the schema where our table resides into the data share. And then we add the table that we want to share with the consumer to the data share. And finally, we grant usage on this data share to the namespace of my consumer Redshift cluster. And as I said before, I have already ran all these commands, so I'm going to show you the result. But before that, to be able to query this data on the consumer side, which in our case is the Redshift cluster in specialist department, we need to run only one command, and that is to create a database from the data share of the namespace of the producer Redshift cluster namespace. After that is done, if I run this query now, which queries the table, the database that we just created, and order the record by event time, we should get the same result. So we can see that the latest record here is for 28th of September, 9:46. If I go to the producer, 28th of September, 9:46. So the solution we just saw is secure, firstly because the producers can decide what data to share with the consumers, and then on the consumer side, the administrators decide who gets access to what part of data that is shared with them. It's very cost effective because the cost of storing data is only incurred to the data producer. The data consumers do not pay anything for storing that data because data is not moved. They just bring the processing power that is needed to query and analyze the data. And also it's very performant. As soon as the data is written to a storage layer by the data producer, it's available to be queried on the consumer side. Now, we are going to expand this architecture a little bit. As I said, we are going to see how we can share data stored in S3-based data lake across different accounts. And then we will use a feature of Amazon Redshift called Spectrum to query that data from the data lake and combine it with the data that we have already streamed into our Redshift cluster. This is a little longer, so I'm going to get off stage so that we can focus on this. This is the file that has patient allergy information. It has a few different columns such as a patient ID, Medicare hash value, a patient's blood type, and a lot of information about different types of food allergies, as well as any drug allergy that the patient might have. I have gone ahead and stored this file in my S3 on the producer AWS account. And because I have crawled and cataloged this data using AWS Glue crawlers, I can see the database and the table that points to the file that is stored on S3 in AWS Lake Formation. This is the table, and this is the schema that matches the file that we saw earlier. Because this data is accessible, this table is accessible now via Lake Formation. As I mentioned before, I can control access to this data at different levels. To share this data with the consumer account, there are a few steps that we need to complete over here on the producer account. First step is to grant access to this database. To do so, I select the database, go to Action, select Grant, and here I can grant access to this data to the IAM users and roles in the same account, SAML users and groups in the same account, or external accounts. So I go to my consumer account, copy the account ID, come back here, paste the account ID, press enter. Database is already selected for me, and I'll allow the consumer account to be able to describe this database, which is basically allowing them to see the tables available in this database. And I want that permission to be grantable. As I said, I've already run all these commands, so you would need to press grant here, but because it's already done, I'll go cancel. The next step would be to grant access to the tables in this database. So same steps. I select the database, go Actions, Grant, select the external account, put the account ID here, and here on the tables, I can either grant access to all tables or grant access to individual tables. I select the table I want to grant access to, and here I want the consumer to be able to describe the table, basically see the schema of the table, and also be able to select data that is stored in this account, in this table. I would hit grant in case that is not done before. And that is basically all we need to do on the consumer side. On the producer side, the first step would be to go to AWS Resource Access Manager. And under Shared With Me and Shared Resources, we can see here now that there are 4 Lake Formation resource shares available here. Because I've already accepted the shares, they're all active. And you can see that there's a button to leave this resource share, but if I hadn't accepted, instead of this button, you would have seen an option to accept this resource share. And now that is done, then the same database appears in Lake Formation on the consumer account here. To be able to consume this data, the first step would be to create a resource link of the shared database. This is to work around the cases where the same name is used on the producer and consumer account, for example, the same database name or the same table names. After that is done, we can grant access to this database the same way that we did before. If I want to show you, if I go back to my architecture diagram, the feature that we are going to use on Redshift to query this data is Redshift Spectrum. So what it means is that I need to grant access to my Spectrum role to this database. Database is already selected, and I want that role to be able to describe this table, this database. I would hit grant in the case I haven't done it before. And the next step would be to select the database, go on grant, select the Spectrum role. As you have probably guessed it by now, I need to now grant access to this table. And here I want it to be described
describable and selectable. And I just wanted to point out that as soon as I select the option for selecting data, I'll see the data permission here, which enables me to control access to columns, different columns in this table. And then I would hit grant when I'm happy with the setting there. And then we need to repeat the same steps for the resource link that we created earlier. When that is done, if I go back to my query editor, and if I open another notebook that I have here, when that is done, the only step that you need to take to be able to share, to be able to query the data that is stored in the S3 in the other account is to create an external schema from the data catalog database of our resource link using the Spectrum role. And when that is done, I run this query which points to that table in Lake Formation. And just to validate, we are looking at the same file and same data. Patient ID here, Medicare hash ends with 809, blood type is AB+. If I go to my file, patient ID 1, Medicare hash ends in 809, and blood type is AB+. And now that I have this information, let me close this and run the query again. I can join that table, patient allergies, to the table that receives data in near real time from medical devices, and basically get a more comprehensive view of who the patient is and what sort of care they might require. So if I run this, we can see that we have all the information that streams in from the medical devices, together with additional information such as what is their blood type, do they have any food allergies, and any drug allergies as well. That was the end of part 2 of the demo.
Okay, because we are running out of time, we don't have any time for Q&A, but in case you have some question, please come and find me after the session. I'll be more than happy to have a conversation. Back to you, Blair.
Thanks, Saeed. All right. Oh, hello. The end result. So now we've got a data mesh architecture, and you can see the way from Saeed's demo, where you've got that producer with that familiar modern data architecture, being able to share that data to the consumer, again with that same modern data architecture on AWS, and through the way you can see that all of the permissions are available, so you're able to grant to the right people so they get access from that producer to the consumer account, and then the consumer account is able to get those permissions and be able to give more permissions inside the consumer account as well. So this now becomes a way to build a self-service environment where producers are putting that into the catalog, consumers are able to find that data and be able to find what they need to solve their business problems. Now, all of this can be monitored and audited as well. So even the producer can share that data to the consumer account. They can see what is happening and who's accessing it from the consumer account. So in terms of that trust of sharing data and who's getting access to it, we can help solve that problem too. Now, a bit of a recap. We know that customers want to be able to get more value from their data, that there's lots of news sources and lots of volume of data coming in from various different types of data sources. Customers are challenged when moving from data warehouses and wanting to be able to get to AI and ML. Remember that data maturity model. And then adopting a modern data strategy, remember, it involves people, policies, and technology, especially around governance. But overall, you do need to think about a strategy and how you're going to build that out. You need to evaluate your tools, what you already have, and what makes sense to keep, as well as what new things can you do that maybe offer a better way to do that in the cloud. And you need to look at that, remember, for the insights you're trying to determine, not look at the whole ecosystem, otherwise you'll drown in information. And then AWS has a very large set of purpose-built data stores for you to be able to ingest, store, put that in file storage, object storage, in databases, data warehouses, and do analytics all the way through to visualization, AI, ML, etc. Now, the data movement, I think, is very important. As I said, in public sector, we're seeing more and more demand for that. If you'd like to see more about how that works, please come and talk to us after this session. And then the data mesh architectures, again, we're seeing more people interested in doing this. Being transparent, this is very new. There's no easy push button, just build one. Yeah, we need to work on it together and build something out. So if you need help getting started, there's two things from AWS. A data-driven everything workshop that's going to help us decide, okay, what are the actual problems that you need to work on as a business? Get business involved, determine the outcomes, and then move forward from there. It's about building a strategy. If you already have an idea of what you've got some strategy, you know what you want to do, then a data lab is going to take a problem and be able to accelerate that and help you build an MVP very quickly. If you need to get skills, we have training. There are certifications for database, for analytics, and for AI/ML. So there's training courses associated with those to get you to that certification level if you want to go and proceed and do that. So thank you. We've got our LinkedIn profiles up there. If you want to try and find us, grab a snap of that. But the most important thing, please put in the feedback. It's very important that we get that and understand what you'd like to see. Thanks very much.
Hi all, thanks for joining. We'll take a brief break. We'll start at 3:05 with the next session, Build Threat Detection Model Using ML. Thank you.